Hey guys, back again. This time we're looking at a worked example for Chapter 9, annuities. Now, I know annuities might be new for you, but what we're going to do today is I'm going to show you how to solve them just with compound interest. We won't delve into any of the heavy hitting stuff with annuities yet, the new formulas that we're going to be using in a couple of lessons' time. Let's just look at this as a compound interest problem, albeit multiple of them. So for the first one, we've got calculate the future value of an annuity in which $1,000 is invested each year at 10% per annum for 5 years. So the only difference that really kind of it presents itself in this question, to set it apart from a compound interest question, is the fact that we're doing this multiple times. Now, what we can do is we can effectively look at doing this multiple times. Very similar to how when you were, in primary school learning how to multiply, something like, 5 times 4 is really just 5 plus 5 plus 5 plus 5, isn't it? Well, we're doing something similar in theory here. We're looking at an annuity broken down into compound interest, and later when we feel comfortable with that theory, we're going to apply some harder maths to it. So, first of all, we've got to split it up into different amounts, okay? Your formula is obviously principal times 1 plus I to the power of n. There we go, that worked. So, I'll do the full working for the first one, then the next amount we're going to skip a little bit. Now, the next thing I need to talk about is an assumption we need to make. And let's just read this question again. Calculate the future value of an annuity in which $1,000 is invested each year. Invested each year. It doesn't say when it's invested. So there are two ways that we can look at this problem. I want you to look at this graph, and here we've got time. You've got T0, so that's your starting point. 1 year, 2, 3, 4, 5. There are your 5 years. Now, where are we going to deposit that $1,000 at our starting point? Are we literally going to deposit it, just as we open it? Or are we going to be waiting a whole year before we deposit that $1,000? Theoretically, for the first year, we won't have anything in there. The way that the textbook Jacaranda does this is they assume that and with the wording of the question, we make that deposit after 1 year. So the first deposit is made 1 year after the starting point. Now, I may not agree with this because I feel that defeats the purpose. Why would you organise an annuity if you literally had nothing to deposit straight away? But anyway, that's besides the point. That's how the textbook goes about it. So how we're doing it on a number line is we start at year 0. There's nothing deposited in year 0, so we move on. Let's look at the amount that we're going to deposit at the end of year 1. There is now $1,000 in there. Okay, now let's have a look at how this is going to work. So our first amount was deposited at the 1 year mark. Okay, there is $1,000 in there, as I realise I've 1 year mark. Change the principal to 1,000. So it's going to be $1,000 times your I value in this case is 0.1. It doesn't mention a compounding period, so we assume it is yearly. Now, let's just count out the number of years. Remember, n is not going to be 5. So this $1,000 is in there for 1, 2, 3, 4 years. Okay? And there's your full formula for that. Putting that into the calculator, let's see what we end up with. So the first amount that was deposited at the end of the first year is going to be $1,464.10. Okay, now A2, copying this down for A2, okay, this is obviously the second. I probably should have labelled it first and second year. Okay, now this, even though we have technically a bit more than 2,000 in our account at this point, remember this one's already earning its own interest. It's running its own race. This little lot is now going to be sitting in there for 3 years, okay? So our starting point was here. There's $1,000 in there. 1, 2, 3. It's sitting in there for 3 years. So the amount from, the total amount earned from the $1,000 deposit is going to be $1,331. Notice it's a little bit less. Oops. Notice it's a little bit less because it wasn't in the oven for as long. Okay. So now what we're going to do is we are going to go for the 3rd year. As you guessed it, if we deposit it at the end of the 3rd year, it's in there for just 2 years now. We change it to a 2. We get 1,210. Now, I'm just going, again, to save a bit of space. Oopsie. There we go. $1,210 for that one. So we've just got 2 years to go. We've just got the 4th and the 5th year to go. So I'll quickly just pop those in there. Delete these. Okay. I'm just going to quickly calculate the 4th year. And then we're going to do the same for the 5th year. Now, I'll talk you through the 5th year in just a moment. 1,000, don't know why I need a calculator for that. $1,100 for the 4th year. Now, obviously that's when you have just 1 year. When we get to the end, that is the 5th year deposit, we are just putting $1,000 in there. It's not earning any interest. Now, that would mean it's to the power of 0. 1,000 times 1 is just 1,000. Or, as we said earlier, just $1,000. Okay? Now, the future value, that's what we need to find now. Backspace this. So the future value is going to equal the sum of all of these. So 1464.1 plus 1331 plus 1210 plus 1100 plus 1000. We enter all of that into the calculator and we are going to get our answer. So I'll quickly just do that now. $6,105.10. Okay, that is the future value of our investment. Okay, over the 5 years we deposited $5,000 and it's grown to $6,105.10. Now, obviously, if we put all $5,000 in based on those conditions at the very start, we'd have ended up with a lot more. Just for argument's sake, I'll work that out now. So if we just deposited that $5,000 at 10% per annum compounding yearly, we'd actually would have ended up with $8,052.55. But that's how annuities work. They deposit $1,000 every year, and that's what they ended up with. Okay, so there's the future value of the annuity using compound interest. Okay, I'll just reset this. So here we've got calculate the future value, annuity value, for the first 3 months of a car loan of $15,880, compounded monthly at 6% per annum with monthly repayments of $210 each month. Write your answers correct to the nearest cent. So, first of all, to work out the first amount, here's how I would go about doing it. Okay, you start with your previous amount, $880. Okay, for questions like this, we always assume that you calculate the interest first and then you make the repayment after that. Now, what we're going to do is we are going to, first of all, find the interest that is charged on that. So we're going to times it by 6%. So 1 plus 0.06, just using the compound interest formula here. That's going to be divided by 12. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay. And then that is going to be to the power, I'd say just 1 at this point, okay? And then what we're going to do is, that's going to give us our new amount, and then from there we take away a repayment of $210. So I'll put that into the calculator, I'll see what I get. Okay. I'm calling it the amount after 1 month. Okay, then obviously 2 months, 3 months is going to be $15,749.40. Notice how that's lower, okay, than our starting amount, okay? But obviously not $210 lower. Okay, so here we took our original amount. We then added the interest to that and then took away the repayment. Okay, now for the next one, okay, I'm just going to take this, substitute it down here. Now what we're dealing with is 2 months. So after 2 months, what we do, instead of using the 15,580, because this is a reducing balance loan, okay, in effect, we take our previous amount, the $15,749.40. Okay, the rate hasn't changed, the repayments haven't changed, and now what we do is we simply just sub that in. So 15,749.4 times the exact same thing we just did before. This time, just copy and paste it down. I get $15,618.15. Okay, just put the units in there, make it look a bit neater. There we go. Okay, so we see how it's going down. All right, now we'll go to the 3rd month. Again, as you've probably figured out, the process is very much the same. This time, instead of 2 months, it's 3 months. Instead of using our $15,749, it has reduced once again to $15,618.15. And as we spoke about earlier, this is how these reducing balance loans work. Okay. This is how they kind of make their money. If you miss a payment, you start falling quite far behind. So, putting that in, dotting the I's, crossing the T's, we get $15,486.24. It always wanted to the nearest cent, so that's how we're doing it. And there we go, guys. We can see how it's decreasing over time. Okay, and that's all I've got for you. So hopefully this helped you, like kind of as an introduction to annuities. We'll cover some more hard-hitting ones in the future, particularly looking at present value and how that works, as well as perpetuities. But for now, that's everything you need to get started on your annuities.